So my name is Iolanda Ialongo. I work here in Helsinki in a abnormally hot weather, and we will talk to you about the this service that we recently opened in a demo version that is called the Emission Observatory Pilot for Africa, and you can already access at this website emissionobservatory.org. And the project was this is the sort of the result, or the first results of a project funded by the Research Council of Finland to basically build a map service online, as many tools that you already saw today, for specifically focusing on monitoring man-made greenhouse gas and air pollution emission sources, and especially we focus on point sources. So that those that can be isolated from the background and not area sources. And the main idea is to provide, using satellite data, improved and transparent emission information, especially focusing on the African continent. And this is a project that is ongoing, and we welcome new collaboration. So while you listen to this presentation, you can already think about some potential idea for collaboration if you are interested. So in the platform, we make use of satellite observation atmospheric composition that have been introduced to you somehow already today. But we focus on those satellite instruments that can observe air pollutants and greenhouse gases like nitrogen dioxide, carbon monoxide, methane, carbon dioxide, and sulfur dioxide. And all these observations are so-called indirect observations, as satellite instrument of those types of data only measure solar radiation backscatter from the Earth's surface to the satellite, and so they are dependent on the presence of sunlight or not. So if it's cloudy or if there is no sun, those will not be available. That there is this limitation. But maybe in Africa this is a smaller problem than, for example, up here in Finland. And this type of observation we think they can provide really valuable information, especially over areas where ground-based networks are not available or are difficult to collect or to maintain for different reasons. So there's a lot of potential in using these satellite data, of course. And largely, this satellite observation that we use in this service are sort of derived from satellite that flies on polar orbits. So they have a global coverage in a certain amount of 1 or more days, and you have sort of the overpass of the satellite always at the same time during the day, and the pixel size can vary between few kilometers to tens of kilometers. That this is the order of magnitude you are talking about for these atmospheric products. So these are some of the example of some instruments that we have been using for research, but now we want to transfer, of course, as everybody here, for example, in the Copernicus network, is trying to distribute this data and to use this data for sort of applications. And maybe our FMI, our history starts with this NASA satellite, OMI satellite instrument that has been providing already in 20 years trace cases, observation of trace cases, but nowadays we are shifting towards the use of TROPOMI, which is a Copernicus flying on a Copernicus Sentinel-5 precursor satellite, and providing similar observation and methane observation as well. And then concerning CO2, also we use observation from OCO2 and OCO3, which are the instrument that provide sort of are maintained by NASA. But we hope to include in the system as many data as possible, including the CO2 and observation that will become available once which is an European mission, which will be available when we will be available maybe in a few years' time. That will sort of combine greenhouse gas observation and and sort of short-lived gases observation together to monitor man-made emission more efficiently. And here are some examples of the air pollutants and greenhouse gases observed from these satellites. Maybe the most used one is the nitrogen dioxide observation, and it is a short-lived gas, and it's quite easy to monitor. It's emitted through fossil fuel combustion largely, and it's a very good indicator for human activities. But then also more recently, methane and the carbon dioxide observation have been used for monitoring individual plumes from individual sources, such as oil and gas facilities and power plants. And there is a step that needs to be taken to go from the satellite-based concentration to the actual emission that is given in let me take this off, I apologize. It's given in the amount of pollutants released into the atmosphere in a specific time interval. And in this specific, there's several ways to do that, especially generally using inverse modeling. But we decided to use the so-called data-driven emission estimation method that basically only use external wind information to derive, transform sort of the concentration into the emission, and that's what you will see in this web service. We decided to focus on 4 sectors: economic sector, the energy sector, as I said, coal burning power plants, and I will show you some example. Oil and gas industry, mostly responsible for methane emission and also gas flaring related emission, and then mining sector, and then of course urban emission from cities in Africa. Some of them are mega cities. Yeah, so this is the website, and I will now switch and go to my web browser. So this is the page that has been, I hope you can still see this, that has been put it out in a demo format last week. So you're the first one to be demoed to. Let's see how it goes. So the page looks at the moment something like that. We have an email, which is emissionobservatory@fmi.fi, where you can contact us if you have a further question. But the main idea of this page is to have collect all these different point sources and to provide information about their emission using satellite observation. There is this main page, which is for the data, and I will illustrate it in a minute. And then there are all these other pages where we plan to include some information about the methods, also some training material, and also to sort of adapt the content of the page based on some of our collaboration and user needs. But
2 minutes,
so here, yeah, that's perfect. We have some categories that we are collected here. You can switch it on and off if you are interested in specific topics. So as I mentioned, we have power stations, cities, mining, and oil and gas, and then others, so miscellaneous of, and then the continent, but I will not talk about that because it's going to change soon. But for example, concerning, for example, the mining sector is this orange point here. This is an historical case that we studied a long time ago, where we basically analyzed the emission of sulfur dioxide from a copper smelter, and we used satellite data to verify this drop in SO2 emissions that we calculated using these methods, these direct methods. And we observed how the implementation of a sulfur capture plant in 2005 was actually working right, and we helped the company implementing this new technology, clean technology, to verify their results. And you see in the page there's a little bit of material, some papers or references, so you can sort of educate yourself with those. And another example is, for example, this that is concerning all the cities that we have. Let's say let's go with something in Kenya, as we were talking about Eastern Africa. And so we monitor every city using these, in this case, using nitrogen oxide emissions. So we transform the concentration from the satellite into emission using this, what is called the divergence method. And that is then described here a little bit. And then you can highlight the point sources. Here it's a cement plant, and then the city, and then some mining site that was identified through this map. And so you have one of these maps for each of the cities. And then the last example, maybe now quickly, is where we here in South Africa, where we combine two different data sets. On the bottom, you have this is a Tropomi nitrogen dioxide observation, and then on these are all coal burning power plants. You see these plumes moving away from the source with the wind, and then on top of that is the CO2 observation from the CO2 satellite. So these are two different instruments, but they are nicely co-located with each other, and we derive emission also from these plumes. You can zoom in and out and see what you have on the bottom, of course, and we have emission provided for these sources as well. And so you have all this kind of example. You can go there and then check it out. And this is all I had.
Yeah, thank you very much. I think this was very interesting, and it's so nice portal. Actually, even we are the first ones. It looks so good. Iolanda, thank you very much. And let's go. I saw some questions on chat. We have 5 minutes Q&A session. And of course, you can contact with this email as it is shown here, I think, always. And also, you can also leave your contact address in the chat, so Yolanda can contact you directly. But let's go to questions. I saw some few questions, like I think one of them answered already with Carolina.
Yeah, sharing the link, it's there.
Yeah,
yes.
Yeah. How your data inform emission compliance enforcement bodies to ensure compliance on emission limits to the particular region or country?
Yeah, so what we find, of course, this is still this emission estimation, they are not perfect neither, but in many, so there are some uncertainties that we try to give to attribute to, and we will include more and more information about that. But what we found, for example, compared to inventories, especially, for example, we studied a lot in South Africa, that a lot of these sources, for example, this Secunda synthetic fuel plant is completely missing from the inventories. So at least even though there are some uncertainties in deriving emission from satellite, they can certainly be used to identify sources that are not present in the inventory. This is the largest source of CO2 in the world, and is not present in the official inventories. So at least this is a strong point for satellite data to provide information on missing sources in the existing inventories. But of course, also like a lot of work needs to be done to provide good uncertainties on these numbers so that it can be used for compliance monitoring.
Thank you. I think David Ongo says that collaboration. So maybe just David, I think Yolanda's contact address. Yeah, you can.
Yeah, you can call me or send it to the Emission Observatory email. Is going to go to me anyway. So whatever it's easier for you.
And also, I remember, Yolanda, as you, at the beginning of the presentation, you said, because previous meetings that we had, that you like to have some kind of also the institute data that you want to collaborate with this. That's correct, kind of indicator.
Of course,
yeah. So maybe that could you could maybe
if any idea on, for example, areas that we should look at, or activity data, or some sort of an anthropogenic activity that you have that you would be interested in, or comparing with other data, all those are possible ideas for collaboration, even just to combine data with somebody else. But we are now focusing on Africa, but also that is not a limit either. So
Right. Are they, I think these are the chats. Are there any questions online? I mean, directly you can raise your hands. If I can see it. Or you can just speak if I don't see it. Yeah, and the whole presentation, as Carolina mentioned before, will be available. And then there, I assume that all these contact persons of speakers are there. So please, or if you cannot find anything, that you can, the last thing that you can contact with us as an organizer. So I would like to thank Yolanda, then move to the
thank you.
next speakers.